Okay, pre-algebra today lesson is scientific notation. So this is an application of decimals. In chemistry, there's a big number, Avogadro's number, the number of molecules of gas in a volume that's called a mole. So the number of the number of molecules of gas in a mole is 602 sextillion, 214 quintillion, 76 quadrillion. We don't like to use this number because that's just too long to say, so we round this number off and use exponents in order to help us. So we write this number as 6.02 times 10 to the 23rd. It means 6.02, and then you're going to move the decimal place 23 times for that number. So we can represent a number by a number between 1 and 10, okay? And then a power of 10. So every number can be written in this form. Every number can be written in the form a times b to the 10, where a is a number between 1 and 10, and b is an integer. So if I think about 34,000, so 34,000 I know that if I want to get a number between 0 and 10, so 3.4, I need to move the decimal 4 places. So what I could do is I could multiply this number by 10,000 over 10,000. That's just the number 1, okay? Now, if I think about it, what is 34,000 divided by 10,000? All that means is the decimal is going to move 4 places to the left. So that is 3.4 times 10,000, or 3.4 times 10 to the 4th. So this is the number in scientific notation. It's a number between 1 and 10 multiplied by a power of 10. So one way to think about it is, in order to get from 34,000 to 3.4, I had to move the decimal place 4 places to the left. So if I made it smaller by 4 decimal places, this is making that number smaller by 4 decimal places. This is making it larger by 4 decimal places. So if I look at this one, a number between 1 and 10, negative 5.65. And I'm going to need to make that smaller, so the decimal moves 1, 2, 3, 4, 5, 6, 7 places. So if I made it smaller by 7 decimal places, then you could make it larger by 7 decimal places going in reverse. So think of it, you're multiplying this number by 10 to the 7th over 10 to the 7th. This bottom part is moving the decimal 7 places, okay? So if you move it 7 to the left, then moving it 7 to the right keeps the number the same. If I look at this one, a number between 1 and 10, 4.00. In order to get that, the decimal has to move 3, 6, 9, 10, 11 places. So if I made it smaller by 11 places, then this would get me back to the original number. Number between 0 and 10, 6.55. In order to make that smaller number, the decimal had to move 3, 6, 7 places. So times 10 to the 7th. Now, one thing to keep in mind, when I look about 10 to the b, if b is a positive integer, this indicates repeated multiplication by 10. So what we mean by this is 10 to the 3rd is 10 multiplied 3 times. Now when b is a negative number, 10 to the b means repeated division by 10. So what I mean by that is 10 to the negative 2 means I'm dividing by 10 2 times. So let's look at this one. This number is 0.000056, okay? So the number that's between 1 and 10 is going to be 5.6. 6. Okay. Now, in order to make that happen, so you've got 0.000056. Now, in order to get that to be 5.6, I'm making the number larger, moving the decimal, 1, 2, 3, 4, 5, 6 places. So what this means is when you multiply this times this is how I get 5.6, okay? And then I'm going to have to divide by 10 to the 6. So when you're dividing by 10 to the 6, this number is just 10 to the minus 6. So this b, the exponent is negative 6. So this number is 5.6 times 10 to the negative 6 power. And what you could do is if you did this operation, you would move the decimal 6 places to the left, you would end up with this original number. So let's look at this. The number that's between 0 and 10 is going to be 6.02. So this number is negative. So I would need to get that to happen, I would make the number bigger by 1, 2, 3, 4, 5, 6, 7 powers of 10. So to make it smaller would be this. Here the number would be 5.65. 1, 2, 3, 4, 5. If I made it larger by 5 powers of 10 to get back to the original, I would make it smaller by 5 powers of 10. Here the number between 0 and 10 is 4.56. In order to get to 4.56, I'm making it larger by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 powers of 10. This would make it smaller by 14 powers of 10. Here, 6.55. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 to the negative 9th power. Now, if I look at this one, this is not scientific notation because the number in front is not between 0 and 10. So to make this number 3.5, that would make it smaller by 2 powers of 10. So in this case, 3.5, if you multiply by 10 twice and then by 10 45 times, this is 3.5 times 10 to the 47. The next one, this number needs to be between 0 and 10, negative 7.21. If I do that, I'm making it smaller by 2 powers of 10. So all I'm doing here is I'm adding those exponents to get this, okay? So the same thing here. When I add these exponents, 4 and negative 2, I'm going to get negative 7.21 times 10 to the negative 2 power. This one, the number needs to be between 1 and 10. So if I make this number 3, in order to do that, I have to make it larger by 1, 2, 3 powers of 10. So this is 10 to the negative 3 times 10 to the negative 5. When I add those exponents, 3 times 10 to the negative 8 power. Here, to make this number between 0 and 10, 4.566. In order to do that, I make it larger by 1, 2, 3 powers of 10. Add those exponents, 4.566 times 10 squared. Multiply these numbers. Now this is why we like scientific notation. rather than multiply the large number you see there we started out with, which was Avogadro's number, we can say this is 6.02 times 10 to the 23rd, okay? And I want to multiply that by 1500. Well, this is 6.02 times 10 to the 23rd. Write this number in scientific notation. That is 1.5, okay? In order to do that, I had to make this number smaller by 1, 2, 3 powers of 10. So it's this. So now, in order to do this multiplication, 1.5 times 6.02, so that's a 0. So this is 9030 and 3 decimals, 9.03. This is 9.03. And I multiplied by 10 23 times and 3 times. So that's 10 to the 26th power. Okay. So I multiplied two very large numbers, but it's easy when I've got the scientific notation. So if I multiply these together, 4 times 2.1 is going to be what? 8.4. And then you multiply by 10 a total of 5 times. And the next one, 10 is going to be multiplied by a total of 5 times again. And 4 times 3.1, that's going to be what? 12.4 times 10 to the 5th. Now that's not complete scientific notation because the number is not between 0 and 10, or 1 and 10, so 1.24. If I make that smaller by a power of 10, I have to make this number larger by a power of 10. So 1.24 times 10 to the 6th. Next number is going to be negative, so 3.1 times 2.1. So 3.1, 2.1. So this is 6.51. And then when you add your exponents, another way to think about this, this is 10 times 10 times 10 times 10 times 10 over 10 times 10 times 10. That's going to leave you with 10 squared. And you add those exponents, 5 minus 3, you get a 2. The next one is going to be a negative number as well. So 2.1 times 4.5. So that's going to be 9.45. And then multiply by 10 9 times, divide by 10 2 times, just add those exponents, 10 to the 7th power. Now when you're doing division, similar process, you've got 4 times 10 5 times over 2 times 10 3 times. So you're going to end up 4 over 2 is 2 times 10 squared. The other way to think about this is all I did to get those exponents, if you subtract 5 minus 3, you'll end up with the 2 in terms of the exponent. So you don't have to write out those powers of 10 every time. So when I'm multiplying exponents, multiplying powers of 10, I add the exponents. When I'm dividing powers of 10, I subtract the exponents. So here, 4.04 over 2.02, this is just 2 times 10, and if you subtract those exponents, this is 2 times 10 to the negative 1. If you looked at that, that would be 10 times 10 over 10 times 10 times 10. Dividing by 10 one time, that's the meaning of that negative exponent. 4 divided by 2 is just 2. times 10 to the negative 5 minus 3. This is 2 times 10 to the minus 8. 14 over 2 is 7 times 10 to the negative 1 minus negative 6. This is 7 times 10 to the 5th power. 5.09 divided by 2.07. So let's do this operation. 2.07, 5.09. Move the decimal. So 207 goes into 509. I think it will go into there 2 times. And that's going to give me 414. This is 5. 10 minus 1 is 9. Okay, 95. So 207 goes into 950. I think that is 4 times. So this will be what? 28 and 8. 10 minus 8 is 2. 4 minus 2 is 2. And 122. 207 will go into 1220. So it would go into there, I think 5 times. So that's 1,035. 10 minus 5 is 5. And this is an 8. $185. And so let's see, I believe it will go into there 8 times. So that's going to be 1656. 10 minus 6 is 4. And 14 is 9. 194. So 2.458. And I can just stop there. Times 10 to the 2 minus 4 power. So 2.458 times 10 to the negative 2. Next one, 4 divided by 2 is just 2 times 10 to the 0. You could leave it like that, or this is just the number 2. Either way. Now, when it comes to adding or subtracting with scientific notation, remember, we can only add or subtract like terms. So this is just like 6.03x plus 1.504x. You would add them together, 6.03 apples plus 1.504 apples. So you're just adding like terms. So if I add 6.03 to 1.504, I get 7.534. So this is 7.534 times 10 to the 3rd. This one, I have like terms, okay? So 5.01 minus 6.01, this is negative 1 times 10 to the negative 4th power. Next one, I need to distribute this. This is what, 6 times 10 to the negative 1 plus 3 times 10 to the negative 1, which is 9 times 10 to the negative 1. Now here, I do not have like terms, okay? So I got to figure out how can I make these like terms. So I can change, so if I look at this, I probably need to change one of these so that it does become like terms. I can rewrite this guy as 0.415. I have made it smaller by 1 power of 10, right? Then I need to make that exponent larger by 1 power of 10, okay? Plus 5.15 times 10 to the 3rd. Now I have like terms. I can just add these together. 5.15 and 0.415 is 5.565. So 5.565 times 10 to the third power. Similar with the next one here. If I look at this, in order to get these to be like terms, so I can write this as 0.41, okay? That means I just made it smaller by a power of 10, right? I need to make 10 to the negative 2 larger by 1 power of 10. So this is 6.1 times 10 to the negative 1 minus 0.41 times 10 to the negative 1. So 6.1 minus 0.41. So 10 minus 1 is 9. 10 minus 4 is 6. So you get 5.69. So 5.69 times 10 to the negative 1. Same thing with the next one. I can make this a 0.1. If I make that smaller by a power of 10, I make the exponent larger by a power of 10. Now I can add these together and you get 6.12 times 10 to the 23rd. And that should lead you up into the homework for this section.